Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning everyone. So today I am going to teach you about the third chapter in organic chemistry, which is benzene and its derivatives. So basically benzene is an aromatic compound. So there are three subtopics that we are going to cover today. First one is introduction to benzene, where I will explain to you about the terms that we are going to often heard in aromatic compound chapter. And the second one, we are going to learn about the nomenclature of benzene and its derivative. And third one, we are going to learn about the chemical properties of benzene and its derivatives. So let's go for the chapter 6.1, 13.1 and 13.2. We are going to learn about what is aromaticity, KEKULE'S structure, and resonance structure of benzene. And then we are going to learn on how to draw the structures, name the benzene derivatives according to IUPAC nomenclature for monosubstituted benzene, disubstituted benzene, and tri- and tetrasubstituted benzene. And third one, we are going to apply the IUPAC rules to name compound with C6H5, which is phenyl, and C6H5CH2, which is benzyl. So both of these are the what we call it benzene derivatives. Okay. So all these are the keywords that you are going to often see this in the chapter aromaticity. Okay, so let's go to look at this slide. So this is Friedrich August KEKULE. So he is a German chemist, where in 1866 he proposed a cyclic structure for benzene. So aromatic compounds. So in early times, compounds are called aromatic because of their pleasant odors. So disebabkan oleh bau benzene or aromatic compound yang sedap, so that's why we name the compound aromatic compound. Okay, and today we use the word aromatic to refer to benzene and its structural relatives. Alright, so aromatic compound is a cyclic conjugated molecule or ion that is stabilized by pi electron delocalization, and it is characterized by substitution reaction. So if we see here, this is the KEKULE'S structure. So KEKULE'S was first formulate a reasonable representation of benzene. So first dia kita represent the structure of benzene here, and we then use this structure to represent benzene. So the KEKULE'S structure suggests the alternating double and single carbon bond. So if we see here, like the double bond and the single bond is arranged alternatingly. So dekat sini ada double bond, dekat sini single bond, double bond, double bond, and single bond to form a benzene ring. Okay. So benzene is actually a resonance hybrid of two KEKULE structure. So it is actually this one. So if we look at here, this is double bond here is a pi electron. Okay, so this pi electron will have the resonance structure where this will moving dekat sini. Okay, and then this move dekat sini, ni move dekat sini, ni move kat sini. So ini adalah resonance structure untuk ni. So the pi electron inside the benzene ring is constantly moving lah. It's constantly delocalizing around the benzene ring. So that's why this is like, so this structure is equivalent to the resonance structure of the two KEKULE'S structure. So this is called resonance hybrid. Okay. Alright. So next. So this is the what we call it, the hybridization for the benzene ring. So where it has the sp2 hybridization. Alright. And the 6 pi electrons completely delocalize around the ring. So this is what I said just now, where the 6 pi electron yang dekat double bond tu, dia constantly moving around the ring. Sebab itulah tadi masa kita tengok tadi, the structure resonance hybrid dia bulat macam ni. Okay. Alright. So all 6 atoms, all 6 carbon atoms and 6 p orbitals are equivalent. Alright. So the circles represent the 6 pi electrons distributed over the 6 atoms of the ring sebab they're constantly moving. Okay, so there are 4 structural criteria that must be satisfied for compound to be aromatic. So the first one is it must be cyclic and planar. The second one, it must be completely conjugated. The third one is that every atom have a p orbital and it have the unhybridized p orbital and sp2 lah. And then it must contain particular number of pi electron, which then obeys the Huckel's rules for it to be the aromatic compound. Okay. So let's look at Huckel's rule. Alright, so Huckel's rules is first introduced by Eric Huckel in 1896. No. Okay, that one is dia punya tadi hidup, sorry. So Huckel's rules ni dia bagi tahu yang for the structure to be aromatic, it must be a cyclic compound, planar, and completely conjugated compound that contain 4n plus 2 pi electron, where n is equals to 0, 1, 2, which is integers lah. Okay, so if it follows this criteria, then the compound will be the aromatic compound. And the pi electron must have 2, 6, 10 or 14 electron and so forth according to the equation for n plus 2 pi electron for it to obey the Huckel's rule. Okay, next. Okay, so let's look at this structure. So we have benzene. So as we know that the one double bond here, dia merupakan 1 pi elektron, and pi elektron mempunyai and pi bond mempunyai 2 elektron. So kalau dia ada 1, 2, 3 pi bond, bermakna dia ada 2 kali 3, 6 pi elektron. So dekat sini kita tahu yang 4n plus 2 pi is equals to 4 times 1 plus 2 pi. So dia ada 6 pi elektron. So kita tahu n dia bersamaan dengan 1. So bila n dia sama dengan 1, so this structure obeys Huckel's rule, which means that it is cyclic, planar, completely conjugated double bond in the ring. So dekat sini dia adalah aromatic compound. Okay, so let's look at naphthalene. So naphthalene dia ada 10 pi elektron, 1, 2, 3, 4, 5 pi bond. So 5 kali dengan 2 sama dengan 10 elektron. So 10 elektron, kalau kita gunakan this formula, kita akan dapat n sama dengan 2. So when n equals to 2, it also obeys the Huckel's rule. And this structure is also cyclic, planar, and completely conjugated double bond in the ring. So this structure is also an aromatic compound. Okay. So now we are going to look into how can we name the benzene derivatives. Okay. So many organic molecules contain a benzene ring with one or more substituent. So and many common names are recognized by the IUPAC system. So for example here, common name dia nama dia TOLUENE. Okay, and IUPAC dia adalah methyl benzene. Okay, because this is its substituent and the parent is the benzene. Okay, so let's look at the monosubstituted alkene. So monosubstituted alkene ialah monosubstituted benzene. So monosubstituted benzene is the benzene yang ada satu substituent. Okay. So bila dia ada satu substituent, so benzene ni adalah parent name dia, and the substituent is indicated by a prefix. So here we have fluorine as a substituent and the benzene ring as the parent. So the name is fluorobenzene. Okay, and here we have chlorine as dia punya substituent, so the name will be chlorobenzene. And now we have bromine as its substituent, so now the name is bromobenzene. Okay, and then we have nitro group as its substituent, and now we have nitrobenzene. And then we have ethyl group as its substituent, so the name is ethylbenzene. Okay, however, the IUPAC system also allows some common names to be retained. So this one, we have methylbenzene here as its IUPAC name. but its common name will be toluene. Okay, and then we have hydroxyl benzene here, and its common name is phenol. And then NH2 here, nitrile group, amine group here. So the common name is aniline. And then we have carboxylic acid here as the substituent for the benzene ring. And the common name is benzoic acid. And the aldehyde is benzaldehyde. And lastly, the common name for the ketone benzene is acetophenone. So, semua ni asalnya, asalnya dia ada IUPAC name masing-masing, tapi IUPAC system dia allow some common names or special name to be used during the naming. So after this, when you see this kind of structure, you need to use the special name, the common name untuk namakan diorang. Okay? Alright, next. We are going to look at the disubstituted benzene. So, kita ada dua jenis disubstituted benzene. First one, if we have the two same substituent, and the second one, if we have two different substituent. Okay, for disubstituted benzene, kita ada special terms that we use to name them. So, kita gunakan position of substituent dengan menggunakan what we call it terms ortho, meta, and para. Okay, tapi kita boleh juga gunakan number untuk namakan diorang. So, for example, we have this 1,2-dibromobenzene. Okay, so dekat sini, dekat nombor 2 ni adalah ortho, meta, and para. So, kita akan namakan diorang as ortho-dibromobenzene. So, secara tak langsung kita tahu yang kalau ortho-dibromobenzene maksudnya ada dua bromin bromin yang pertama dekat karbon nombor 1 dan bromin yang kedua dekat karbon nombor 2. Okay, and then we have this one. This position is para. So, kalau kita gunakan number untuk namakan diorang, we will use 1,3-dibromobenzene. Okay, tapi kalau kita gunakan position substituent dia, so this is meta, ortho, meta, para. So this is meta-dibromobenzene. And last one, if we have this structure, so kalau kita tengok IUPAC dia by number, so dia adalah 1,4-dibromobenzene. But if we use the position substituent, it will be named para-dibromobenzene. So, alright. Next. Okay, so kat sini kita ada 1, 2, okay, group nitro. So dekat sini kalau kita namakan dia ikut nombor, kita akan namakan dia 1,2-dinitrobenzene. Tapi kalau kita nak namakan dia ikut position, kita akan namakan dia ortho-dinitrobenzene. Okay, same goes to this one. Okay, kita ada 1,3-dinitrobenzene. Tapi kalau kita nak namakan dia ikut position, kita akan namakan dia jadi meta-dinitrobenzene. Okey, yang ni pun sama. Kalau biasa kita akan namakan dia dengan 1,4-dinitrobenzene. Tapi kalau kita namakan dia ikut position, kita akan namakan dia ikut para-dinitrobenzene. Okey, tadi kita dah tengok how to name the disubstituted benzene when we use two same substituent. Okay, now we are looking at how to name the disubstituted benzene when there are two different substituents in the benzene. So first, we need to select one of the substituent that give new parent name and numbered as C1. So maksudnya, okay, dekat sini kita ada priority untuk jadikan diorang sebagai parent benzene. Okay, so kita akan utamakan this structure carboxylic acid punya functional group. So kalau kita ada functional group carboxylic acid, automatic this benzene ring dia akan jadi benzoic acid sebagai parent name dia. Okay, so kita ada nitro group dekat dekat benzoic acid ni. So kita akan namakan dia 2-nitrobenzoic acid, or kita boleh namakan dia ikut position tadi, ortho, meta, para tadi. So ini adalah position ortho, so ortho-nitrobenzoic acid. Okay, so remember, kita kena select satu substituent yang dia paling priority, yang paling tinggi darjat dia, okay, untuk kita jadikan dia sebagai parent name. Okay, sebab dia sebenarnya benzene, tapi kita nak jadikan sebabkan carboxylic acid ni dia punya king of all substituent, so dia jadi nama baru. So nama baru dia adalah benzoic acid yang kita nampak tadi. Okay, sebelum ni kita tengok tadi kan. Okay, so and then kita namakan dia macam biasa lah. Alright, kita tengok contoh lagi satu. Okay, now kita ada benzoic acid juga, and then kita ada nitro group, and nitro group ni dekat carbon number 1, 2 and 3. So dia kita akan panggil dia 3-nitro-benzoic acid. Ataupun kalau kita namakan dia ikut position ortho, meta dan para, kita akan namakan dia ortho meta. So meta nitrobenzoic acid. Okay, this one point disebabkan nitro dekat position para, so kita akan namakan dia sebagai para nitrobenzoic acid or 4-nitrobenzoic acid. Okay, this one between OH and nitro, OH is the substituent yang paling kita nak prioritisekan dia. Okay, so ini adalah phenol. Okay, sebab ada OH and then benzene ring, so this is phenol. So nitro group dekat carbon number 3, so 3-nitrophenol ataupun meta-nitrophenol. And then ini kita ada NH2, so ini adalah aniline. Okay, parent dia aniline, so bromo ni dekat carbon number 4, so dia adalah 4-bromo-aniline ataupun para-bromo-aniline. Okay. Next, kita dah habis yang DISUBSTITUTED. Sekarang kita tengok kalau dia ada 3 or more substituent. So, position of substituent must be indicated by numbers. And the substituents are listed alphabetically when writing the name. So, kat sini kita ada 1, 2, 3, 4. Ada 3 substituent bromine and kita nomborkan dia. So, ni adalah 1, 2, 4 tribromobenzene. Okay. So, kalau macam ni kita ada setiap sini berlainan substituent. Ada iodo, ada bromo, ada chloro. So, B dulu, baru C and then baru I. So, kita numberkan dia. Oops. So, kita numberkan dia kat sini 1, 2, 3. So, 2 bromo, 1 chloro, 3 iodobenzene. Okay. So, C atom bearing the substituent that define the new parent name is numbered as C1. So, dekat sini kita tahu parent name dia adalah toluene. Toluene pula, phenol, sorry. Sebab ada OH, okay. So, phenol. So, phenol nama parent dia and ada 2 substituent nitro. So, dekat sini 1, 2, 3, 4. So, 2,4-dinitrophenol ataupun 2,4-dinitrophenol. Okay, next. Kita ada benzoic acid sebab ada functional group carboxylic acid kat sini. So, ini adalah 3,5-dihydroxy benzoic acid. Okey, dekat sini kita ada toluene. Okey. So, dekat sini kita ada 2 methyl. So, kita tak boleh nak namakan dia toluene sebab kalau toluene kita ada 1 je CH3 sebagai parent dia. So, dekat sini kita akan namakan dia sebagai 1, 2, 4 bromo sebab B dulu kan. So 4 bromo 1, 2 dimethyl benzene. Okay. So keep in mind that kita boleh gunakan frasa ortho, meta dengan para naming system ni bila kita nak namakan disubstituted benzene sahaja. Maksudnya benzene yang ada 2 substituent sahaja. Kalau 1 tak boleh, kalau 3 dan lebih pun tak boleh. Okay? Alright. So now kita tengok kalau benzene ring ni sebagai substituent. So kita ada phenyl group dengan benzyl group. So Kalau alkyl substituent kita is larger than the ring, maksudnya substituent alkyl kita ada 7 carbon contohnya. So compound benzene akan jadi substituent. Okey, and kita panggil dia phenyl substituent. Phenyl substituted alkane. Okey, contohnya grup yang ini dia punya carbon lagi banyak daripada benzene ring kita. Sebab benzene ring kita ada 6 saja carbon dan carbon yang panjang ni ada 1, 2, 3, 4, 5, 6, 7 carbon. So dia lagi panjang daripada benzene. So benzene akan jadi substituent kita. Okey, so now kita akan jadikan dia, so when this phenyl group is act as substituent, so kita akan numberkan dia untuk namekan dia. So our parent name is heptanes because this is alkane, and then the phenyl group is bonded at carbon number 2, so this is 2-phenyl heptane. Okay, and phenyl has molecular formula of C6H5 ataupun kita boleh gunakan singkatan PH. Okay. Next. Kita ada structure ni. Okay. So kalau chain kita unsaturated ataupun dia ada important functional group, so benzene ring pun kita akan consider sebagai phenyl substitution. Okay, contohnya sekarang kita ada alkane group dekat straight chain ni. So dia akan jadi parent. So ni butane. Okay, and kita akan numberkan dia ikut yang mana dekat dengan double bond dan dekat dengan substituent. So in this case kita akan numberkan dia macam ni lah. So kita akan dapat 1-phenyl 2-butene. Okay. So macam ni kita ada ethanol. Okay, so sekarang ni kita akan dapat 2-phenyl ethanol sebab yang functional group wajiblah kita numberkan carbon dia nombor 1. So sebab itulah phenyl dekat carbon nombor 2. So 2-phenyl ethanol. So apa pula benzyl group? So kalau phenyl group dia tak ada CH2. Kalau benzyl group dia ada CH2. Okay, so kita tengok. Kalau macam ni kita akan panggil dia benzyl bromide. Benzyl bromide sebab CH2 ni adalah benzyl substituent. Benzyl group. Okay, so kita namakan dia benzyl bromide. Okay, and then ini adalah benzyl alcohol. Okay. So now kita ada exercise kat sini. Dia kata give IUPAC name for the following compound. So dekat sini kita ada CH3 kat sini. Kalau awak nampak CH3 dengan benzene, satu CH3 dengan benzene, ini adalah toluene. So toluene and then ini adalah nombor 1. 1, 2, 3, 4. So ini adalah bromo dulu kan, AB. So bromo dulu. So 4 bromo, 3 nitro, toluene. Okey, kalau macam ni pula kita nampak ni adalah carboxylic acid. So ini sebenarnya adalah benzoic acid, and kita ada isopropyl punya substituent attach dekat mana ni? 1, 2, 3, 4 ortho meta para dekat para position. So dia adalah 4 isopropyl benzoic acid ataupun boleh jadi para isopropyl benzoic acid. Okay, next. Kita akan pergi kepada chemical properties of benzene pula. So kita ada dua jenis reaction dalam benzene yang kita akan belajar. So first is electrophilic substitution and second one is yang bawah tu, oxidation dengan halogenation. Okay, first kita akan tengok yang atas ni. So electrophilic substitution reaction of benzene ada 4: nitration, halogenation, FRIEDEL-CRAFT's alkylation and FRIEDEL-CRAFT's acylation. And kita akan belajar on how to draw or illustrate the mechanism to show how the electrophilic aromatic substitution occurs in benzene. Okay, so all 4 of this electrophilic substitution has mechanism. And then we are going to look at the reaction of alkyl benzene, which is oxidation and halogenation. Okay, let's look at this. Okay, so benzene ni dia tak sama macam alkene. So kalau alkene dia readily undergo addition reaction, Tapi benzene tak. So kalau alkene dia boleh undergo hydrogenation, halogenation, hydrogenation, oxidation dengan senang. Tapi benzene tak. Okay, so dekat sini benzene dia tak ada addition, tak ada oxidation dengan potasium permanganate, tak ada, and dia punya addition of hydrogen ataupun reduction of hydrogen sangatlah slow, kecuali if we use at high temperature and pressure. Okay, so kenapa? Disebabkan dia punya stability of its aromatic ring. So benzene ni boleh reduced only under extreme condition. Must be under high pressure as well as high temperature. So dia still boleh undergo addition reaction dengan hydrogen, tapi under extreme condition only. Okay, so benzene ni dia undergo electrophilic substitution reaction. So similar to alkene, benzene is also susceptible to electrophilic attack because of its exposed pi electron. So benzene is a very electron rich species. Okay, sebab dia ada banyak pi bond. Okay, however, benzene ni closed shell of 6 pi electron gives it special stability. So therefore, it undergoes substitution reaction rather than addition reaction. So dia stable. Okay, kita nak tengok dekat sini ada 4 jenis aromatic substitution. So kita ada yang pertama, halogenation reaction. So halogenation reaction dengan Lewis acid. So X2 FeX3 where X equals to Cl or Br. So bila kita substitutekan dia, kita akan substitute H dengan X. Okay, and then kita ada nitration reaction where we use the HNO3 with concentrated sulfuric acid at 50 to 55 degrees Celsius to form a nitrobenzene plus water. Next is the FRIEDEL-CRAFT alkylation, where we transfer the alkyl group into the benzene ring. We replace the hydrogen with the alkyl group. Okay, and then lastly we have FRIEDEL-CRAFT acylation, where we transfer the C double bond OR, okay, into the benzene ring, okay, to form a new product. Okay, so reaction of arenes or aromatic compound involves the benzene ring itself and electrophilic aromatic substitution, which means that we are going to substitute the hydrogen here with bromine. Okay, it's where the bromine is here is electrophile species. Okay, so electrophile dengan electrophile dia akan substituted lah, bertukar tempat, replace. Sebab tu kita panggil dia electrophilic substitution. Okay, so now we have benzene mula-mula. Bila kita undergo electrophilic aromatic substitution with bromine, kita akan dapat bromobenzene. And dia juga involve substituent attached to the ring. So dekat sini kita namakan dia butyl benzene. So kalau kita undergo oxidation, dia akan tukar all the substituent jadi carboxylic acid. So kita akan tengok kejap lagi. Okay, alright. Alright, so let's look at electrophilic substitution. So electrophilic substitution is a characteristic reaction of benzene, and a hydrogen atom is replaced by an electrophile. So kita ada hydrogen and kita ada electrophile species. Contohnya bromine ke, chlorine ke, or any other electrophile species yang kita belajar lah hari tu. Okay, so this electrophile species will then replace the hydrogen atom inside the benzene ring to form a new product. Okay, so untuk keempat electrophilic aromatic substitution of benzene, kita ada three step of general mechanism. Okay, first one is the formation of electrophile. Second one is the formation of arenium ion, and the third step is the loss of proton or deprotonation. Okay, so these three steps ada dalam semua reaction aromatic substitution. Okay, So, kita tengok yang pertama. So, electrophilic aromatic substitution yang pertama adalah halogenation. So, the reactant that we often use are benzene and halogen. And the halogen that we are used is either chlorine or bromine. Okay, so now we have this reaction. Benzene ring react with bromine. So, kalau tak ada Lewis acid, so tak ada observable change. So, decolorization will not be observed. So, color bromine tu tak akan jadi colorless. Okay, kita kena ada FeBr3 for the electrophilic aromatic substitution to occur at benzene. So, kalau tak ada FeBr3 ni, tak akan ada any reaction occurs. So, for the halogenation or for the electrophilic aromatic substitution to occur in the benzene, we need to have FeBr3. Okay, this one is very important. Okay, so kita nak tengok dekat sini. So, benzene, dia does not react with halogen unless a Lewis acid is present in the mixture. So, dia punya Lewis acid tu based on what is the halogen that we use. If we use bromine, then we use FeBr3 ataupun AlBr3. Kalau kita guna chlorine, kita guna Lewis acid FeCl3 ataupun AlCl3. Okay. So, kita nak tengok apa function Lewis acid ni. So, Lewis acid ni function dia adalah untuk kita increase the polarity of halogen molecule and to produce the positive halogen ion. Sebab ini adalah electrophilic species. So, sebabkan kita nak undergo electrophilic aromatic substitution, kita nak substitutekan H plus dekat benzene dengan electrophilic species. So, kita kena jadikan Br dengan chlorine sebagai electrophile dulu. Kita jadikan sebagai positive halogen ion dulu. Sebab tu kita kena guna Lewis acid. Okay, supaya kita boleh undergo electrophilic aromatic substitution. Okay. So, contohnya, macam mana benda ni berlaku? So, disebabkan AlCl3 ni merupakan electron deficient compound, dia akan act Lewis acid dengan cara accepting lone pair electron daripada chlorine atom tadi ni, menyebabkan Cl kita yang sebelah sini jadi Cl+. So, dia akan form AlCl4- plus Cl+. Okay. Sebab tu, okay? And then, kita ada second electrophilic aromatic substitution, which is nitration reaction. So, in the nitration reaction, the reactors that we are going to use are benzene and concentrated nitric acid. Okay, so condition dia mestilah menggunakan concentrated sulfuric acid. Okay, so we have benzene ring react in nitric acid inside the concentrated sulfuric acid. So, we have the nitrobenzene. Okay. So, the next one is FRIEDEL-CRAFT alkylation reaction. So, this is also one of the electrophilic aromatic substitution, and the reactants that we use here are benzene and haloalkane. So, under the condition where the catalyst Lewis acid must be present for the reaction to occur. So, here we have benzene and haloalkane. Okay. Oh, ni... Ya, okay. So, and haloalkane. So, now, the alkyl group is going to be transferred or switch place with the hydrogen, with one of the hydrogen in the benzene ring to form alkyl benzene. Okay, and the keyword alkylation inside the FRIEDEL-CRAFT alkylation reaction means the transfer of an alkyl group to the benzene. Okay. So, example, we have this reaction. So, kita ada this haloalkane, 2-chloropropane and benzene. Okay, with the presence of AlCl3 catalyst, so we will produce this isopropyl benzene. So, this reaction is the FRIEDEL-CRAFT alkylation. Okay. Okay, dia punya HCl adalah byproduct dia, okay? And then next we have benzene with this 2-chloro-2-methyl propane. So with the presence of catalyst, so we will form third butyl benzene. Okay, plus HCl, the byproduct. Okay, next. We are going to look at the last reaction of benzene, which is FRIEDEL-CRAFT acylation. So FRIEDEL-CRAFT acylation have a reactant benzene and acid chloride. So we will form a ketone as a product under the condition with catalyst Lewis acid such as AlCl3. So kalau perasan, semua reaction dalam benzene, electrophilic aromatic substitution, perlukan catalyst Lewis acid. Okay, which such as AlCl3 lah. Okay, so dekat sini kita ada benzene plus dengan acetyl chloride. So kita akan pindahkan the acetyl group ni dekat what we call this benzene ring. Okay, under with the catalyst, with the help of catalyst, so we will form acetophenol. Okay, plus HCl. Okay, other example, we have benzene ring plus acetyl chloride. Okay, ini sama lah acetophenol, lain tak? Okay, so the acylation here means the transfer of an acyl group to benzene. Ini yang kita panggil acyl group. C double bond O attached dengan alkyl group. So alkyl group attached dengan carbonyl, kita panggil acyl group. Okay. Okay, kita ada acetyl group, kita ada benzoyl group. Okay. Okay, last. Okay, kita ada next kita nak masuk kepada chemical properties of benzene and its derivative. Kita nak explain the reaction of alkyl benzene. So ada dua reaction of alkyl benzene. Yang pertama adalah oxidation with hot acidified potassium permanganate or potassium dichromate. Okay, and the second one is halogenation reaction, which is free radical substitution reaction. Okay, so oxidation of side chain. So reactant adalah arene with benzylic hydrogen. Condition dia must be strong oxidizing agent such as potassium permanganate and sodium dichromate. So we need to use heat and followed by the hydrolysis H3O+. Okay, so dekat sini kita ada, so kita nak tahu apa itu benzylic hydrogen. So benzylic hydrogen is hydrogen yang dekat carbon di luar benzene ring. So ini adalah benzylic hydrogen, ini adalah benzylic hydrogen, ini adalah benzylic hydrogen. Okay, alright. So yang bukan kat dalam kat dalam tak, bukan. Yang dekat luar ni adalah benzylic hydrogen. So oxidation ni dia takes place at the benzylic carbon. So alkyl benzene with alkyl group other than methyl degraded to benzoic acid and carbon dioxide. So kalau kita ada ethyl group, propyl group, butyl group, semua tu nanti bila dia undergo oxidation, dia akan form carboxylic acid functional group and water and carbon dioxide. So let's look at this example. We have toluene here. So this is toluene. Sebab apa? Kita ada CH3 attached to the benzene ring. So the common name here is toluene. So toluene, when it undergo oxidation with potassium permanganate under acidic condition with heat, it will form carboxylic acid. Benzoic acid. Sebab apa? Dia tukar CH3 kita ni jadi COOH functional group. Okay, kalau kita ada this, okay, NO2 dengan CH3, so this is also toluene. So this is 1, 2, 3, 4 nitrotoluene ataupun para-nitrotoluene. So when the nitrotoluene undergo oxidation in basic condition with heat, it will form, this CH3 will form a carboxyl group. Okay, so dia akan jadi para-nitrobenzoic acid. Okay, so we need to keep in mind that, okay, alkyl group, regardless their chain length, bila dia undergo oxidation, dan bila ni benzene ring, kalau ada benzene ring, alkyl group yang attach dekat benzene ring, bila dia undergo oxidation, regardless of their chain length, it will converted to COOH. Regardless, dia ada banyak, ada 3, 4, panjang mana pun, okay, yang tak lebih daripada 6 lah kan, dia akan jadi benzoic acid. Okay. Kalau compound yang tak ada benzylic hydrogen macam ni kan, dia carbon ni dia tak ada benzylic hydrogen sebab ketiga-tiga bond dia bonded dengan methyl group. So this fragment or this side of benzene of the alkyl group, dia tak akan jadi COOH. Dia akan maintain sama. Cuma yang ada benzylic acid saja yang boleh tukar bila undergo oxidation. So remember, okay, the carbon chain, the alkyl group chain yang dekat benzene ni, bila dia undergo oxidation, dia akan form carboxyl group. Okay, so dia akan form benzoic acid lah. Tapi kalau dekat substituent tu dia tak ada benzylic hydrogen, dia inert, so dia tak akan undergo oxidation. Sebab tu dia akan maintain the same kat sini. Okay, cuma yang ini saja dia tukar jadi COOH. Okay. Last, kita ada halogenation of toluene. So halogenation of toluene, bila dia cakap halogenation of toluene, dia adalah free radical substitution and must be formed under sunlight. And this process occur is similar to the halogenation of alkane that we learned in the previous chapter. Okay, so kita akan form the free radicals untuk halogenation of toluene ni. So in sunlight, chlorine and bromine atoms substitute the H in CH3 group, not the ring. So maksudnya yang akan undergo free radical substitution adalah carbon chain yang dekat luar ni, bukan dekat benzene ring. So benzene ring dia tak undergo free radical substitution. Okay, so kita ada methyl benzene ataupun nama dia toluene. Okay, so toluene dia react dengan chlorine under UV light and inert solvent, dia akan form the radical dekat sini, dekat carbon yang sini, bukannya benzene. So dia akan form free radical dekat carbon yang ini, and then dia akan form chloromethyl benzene sebab chlorine attach dekat sini. Okay, sebab nanti chlorine ni, awak ingat lagi tak, kita ada berapa step of free radical substitution? Ada 3 step. Ada initiation step, propagation step and termination step. Okay, so kita akan form chlorine free radical dulu, and then kita akan form carbon free radical. Okay, lepas tu kita akan cantumkannya macam ni. Okay, so daripada methyl benzene ataupun toluene, we will form chloromethyl benzene. Okay, so for example here, so we have ethyl benzene CH2 CH3 plus Br2 in the inert solvent under UV sunlight. Okay, so dekat sini dia akan form dekat, so carbon yang ini adalah so hydrogen yang ini adalah primary hydrogen, hydrogen yang ini adalah secondary hydrogen. So biasanya kita akan form the most stable free radical dekat secondary hydrogen lah. So maksudnya kita akan buang hydrogen yang dekat belah sini sebab dia more stable compared to hydrogen yang sini. So that's why bila undergo free radical substitution, the bromine will be substituted at carbon yang ini, secondary carbon. Okay, sebab apa? Dia remove hydrogen daripada secondary carbon. Okay, so just for information, the benzylic radical, this one, okay, yang tadi kita tengok tadi, yang ni kan dia akan form benzylic radical tau. Allah, yang ni kan tadi dia akan form benzylic radical. Sorry, mana tadi? Allah Akbar. Ni dia akan form benzylic radical. So benzylic radical ni is known to be even more stable than the tertiary radical yang biasa-biasa tu. Okay. Okay, so benzoic acid ni is the simplest organic acid to prevent the growth of many organisms. Ni dia punya kegunaan benzoic acid lah. Apa kebaikan benzoic acid? Okay, so now we have the aromatic compound reaction minds mapping. So dekat sini kita tengok yang benzene ring dia boleh undergo 4 types of 4 reaction. So reaction dia adalah electrophilic, aromatic, substitution reaction. And ada 4 lah bawah dia tu. Yang pertama halogenation, yang kedua nitration, yang ketiga FRIEDEL-CRAFT alkylation dan yang keempat FRIEDEL-CRAFT acylation. And kita tahu halogenation ialah di mana benzene ring react with halogen in the presence of Lewis acid. Okay, to form contohnya bromobenzene ke chlorobenzene ke, okay. And then next adalah nitration reaction di mana benzene ring react with nitric acid with the presence of concentrated sulfuric acid to form nitrobenzene and water. And then kita ada FRIEDEL-CRAFT alkylation. So the alkylation here means the transfer of alkyl group into the benzene ring. So dia tukar tempat dengan hidrogen dekat benzene pada mulanya tu. So kita perlukan haloalkane with the presence of Lewis acid AlX3 ataupun FeX3. And last one, we have the FRIEDEL-CRAFT acylation where we transfer the acyl group into the benzene ring. Okay, so we form ketone plus HCl. Okay. So untuk the oxidation reaction untuk toluene pula. So toluene, when we undergo oxidation in acidic condition with heat, it will form benzoic acid. Okay, alright. So compound yang tak ada benzylic hydrogen are inert to oxidation, means dia tak akan undergo oxidation, dia akan remain the same as it is. Okay, as well as toluene juga boleh undergo halogenation, tapi halogenation hanya pada carbon chain dekat luar, bukan dekat benzene ring. Okay, so dekat sini kita mesti kena guna UV sunlight, okay, dengan kehadiran halogen. So dia akan form this one. Okay, so this is halogenation. Alright, so I think that's all for today. So we have finished lecture session for benzene and its derivative. So I hope that you can have like a gist of what is inside the chapter benzene and its derivative, so that bila you masuk tutorial class in the next few weeks, you tak adalah tengah-tengah, macam tak pernah nampak lah benzene ni apa benda jangan nak buat-buat tak tahu, because you have learned this in this lecture. So I hope that you enjoy this session with me, and segala yang baik datang daripada saya, segala yang baik datang daripada Allah, segala yang buruk datang daripada saya. Okay, so take care everyone. So selamat bercuti. See you guys next week. Bye. Assalamualaikum.